So yesterday we started the streaming chapter. So in this chapter, we have first learned what is streaming. Streaming is that allows the data transfer technique. It's a data transfer technique that allows to break down a route into smaller chunks and progressively stream them from server to client as they become ready. So this was how it is done. Like cards take the less time, latest invoice take more time to fetch from server. So by streaming, you can prevent slow data request from blocking a whole page. So we have learned about that yesterday's in the yesterday's stream. Now we have this dashboard. We have this revenue chart, latest invoices. Then we have these cards, nice looking cards. Then we have a sidebar. We have the content only in the home, not in the invoices or customers. We will do that later. Okay, yesterday we learned how we can actually stream the whole page. So here the whole page is streaming. So for example, in the data.ts we have added a promise to of 3 seconds to wait for the data to fetch for like 3 seconds, then it will show. So so that was the whole streaming the whole page, right? So that means when we refresh this, I can still access invoices and customers page, but home is still loading. So it is like streaming, it is still streaming. Everything that do not have data is already rendered before us. So now let's learn how we can stream a component. So far you are streaming a whole page, just I have shown now, but instead you can be more general and stream specific components using React Suspense. Suspense allows you to be defer rendering parts of your application until some condition is met. For example, data is loaded. You can wrap your dynamic components in Suspense, then pass it a fallback component to show while the dynamic components loads. If you remember the slow data request fetch revenue, this is a request that is slowing down the whole page. Instead of blocking a whole page, you can suspend to stream only this component and immediately show the rest of page. So they're saying that this revenue chart is taking the most time, and this invoices component and cards are taking less time to fetch data. So if I click this, all the components are taking time because they are dependent on this. So what we want to do now is we want to make the streaming of like this revenue chart first, then they will be shown independently. They will be shown first because they are taking less time. It will be streaming at that time. So yeah. To do so, you will need to move the data fetch to the component. Let's update the code to see what it looks like. Did all the instances of fetch revenue and its data from dashboard overview page. Okay. Yesterday, we missed one step where they have put the loading and page.tsx in the overview folder. Now there is saying delete all instances of fetch revenue. Okay, delete this line, remove fetch revenue from page.tsx. Okay, fetch revenue. Also remove here. Also remove from here. Now they're saying to import Suspense from React. Import Suspense from React, and then revenue chart skeleton. Revenue chart skeleton from app UI skeletons. So this is a fallback component. Okay, revenue chart. Wait a minute, we have, I think, deleted this. Revenue chart. Okay, we will remove this prop revenue from this. And put it inside React Suspense component. Okay, fallback component will revenue chart skeleton. Fallback component will be revenue chart skeleton. Property revenue missing type but required in the type revenue. Okay, so what is the now there's finally update the revenue chart component to fetch its own data and remove the prop pass to it. They're saying to go to revenue chart and import the fetch revenue backend call in here. Okay, then we will use then we will use revenue here in this. Revenue chart. I think we should remove this if I am correct. Okay, we'll remove this. Okay, now error from both these pages is gone now. Now refresh the page, you should see the dashboard information almost immediately, and while the fallback skeleton is shown for only revenue chart. Okay, let's refresh this. Alright, the cards data is shown, also invoices, but it's still streaming. That's good, we have implemented the streaming. That's a very good user experience. Now let's try to remove this promise. This promise of waiting for 3 seconds. Let's see what happens now. Okay, this is just little bit later because it has a more data than other components. Okay, we have implemented the streaming. Let me just try to do that. Wait a minute. Okay, it's now they are saying practice streaming latest invoices. Now it's your turn to practice what you have just learned by streaming the latest invoice information component. Move fetch invoice down from page to latest invoices component. Okay, so we will do the same thing now. What we will do is in our invoices, in our invoices page. No. I'm doing it a little bit wrong. Okay, in page.tsx, we have to put this latest invoices inside suspense, react suspense. So I have to just remove this from here, patch latest invoices, and let's go to this latest invoices page, then import fetch latest invoices from app data, where it was from, um, app lib data. Okay, app lib data. So we will remove this and cut this from here and copy it in here, and we will remove this TypeScript. That's saying cannot find module app lib data. Okay. I think I've used correctly. After that, latest invoices, we will remove this. Applet data. No. It must be shown like in this revenue chart. Fetch revenue from app lib data. I think this should be also available here. We have the function fetch latest invoices. We have used it here. So why it's not working? Is there any definition for that? Latest invoice. No, nothing happened. So let's close it. Let's go to page latest invoices. I think we have not used fallback. The fallback component we're going to use is latest invoices skeleton. Okay, we have to import this from latest invoices skeleton. Now here we will give it the provide the fallback component latest invoices skeleton. Okay, now we will go to latest invoices. Okay, just import it again. Import fetch latest. Oh, now it's working. Like this is weird. Okay, it's working now. I think we have done the correct thing. Remove the fetch latest invoices. Imported the latest invoices skeleton. Then put the latest invoices component inside Suspense. We have put this whole latest invoices component inside Suspense. Then remember to remove props. Yeah, we have removed the props from latest invoices. Now next is grouping components. Great, you are almost there. Now you need to wrap the card component in Suspense. You can fetch data for each individual card, but this could lead to popping effects as cards load in, and this can be visually jarring too for user. So how would you tackle this problem? To create more of a staggered effect, you can group the cards using the wrapper component. This means a static sidebar will be shown first, followed by the cards. This means to create more staggered effect, you can group the cards using a wrapper component. This means a static sidebar will be shown first and followed by cards. In your page.ts, delete your card components. Delete the fetch card data, import the new wrapper component called card wrapper, then card skeleton. Okay. they have used card wrapper here. Import card wrapper inside our page.tsx. First we need to remove this fetch card data from here, I guess. Then remove this and also remove this, I think. Then we have to import card wrapper. Card wrapper from UI dashboard cards, and then put it here. We have to put it inside Suspense. Okay, we put the card wrapper inside Suspense. Then we have to also provide the fallback component. What will the fallback component? Card skeleton. We have to import in the same skeleton groups we have already imported. Card skeleton. Is it card skeleton? Card skeleton. It's card skeleton. Card skeleton. Okay, we will put this inside this fallback component. Wait. We have to convert it into red component. I think we have to also then move into the cards JSX, import fetch card data. Inside card wrapper component, close this, this cards. We have to import the card data, fetch card data, then uncomment this. Wait a minute, what is the problem? What's the problem? Now we have to import this code, copy this code and paste it in the card wrapper. Alright, so we have fetched the data and use the data points in the cards. Okay, now refresh this. Okay, they are like now shown almost at the same time. So we have now implemented the component level streaming. We have added streaming in cards component, revenue component, invoices. So they will not depend on each other. So they will also not block the whole page. So even if it takes like 10 seconds, it takes 1 second and takes like 2 seconds. First it will be rendered, then this invoice will be rendered, then revenue will be rendered. So they will not block each other. That is the main purpose of Suspense. This pattern you want multiple components, so all cards load in at same time. Load at same time, deciding where to place your Suspense boundaries. Okay, now how we decide where to place suspense boundaries. Wherever you place your suspense boundaries will depend on a few things. How you want to user to experience the page as it streams, what content you want to prioritize. If the components rely on data fetching, take a look at your dashboard page. Is there anything you would have done differently? Don't worry, there is not right answer. You could stream the whole page like you did with the loading T6, but that will lead to longer loading time. One of the components has slow data fetch. You could stream every component individually. We have done that, but that may lead to UI popping up screen as become ready. You could also create a stacked effect by streaming page sections, but you will need to create wrapper components. Okay. Where you place your suspense boundary will vary depending on your application. In general, it's good practice to move your data fetches down to the components and need it, and then wrap those components in suspense. But there is nothing wrong with streaming the section or whole page. That's what your application needs. Don't be afraid to experiment with suspense and see what works best. It's a powerful API that can help you create more delightful user experiences. Great. Move data fetches down to component needed. By moving data fetching down to component needed, you can create more granular suspense boundary. This allows you to stream specific components, prevent UI from blocking. Looking ahead, streaming and server components give us new ways to handle data fetching and loading states, ultimately with the goal of improving the end user experience. In the next chapter, you will learn about partial pre-rendering. Okay, this is the new thing in Next.js 14. A new Next.js rendering model built with streaming in mind. Okay, we have completed chapter 9 here. You have learned how to stream components with suspense and loading skeletons. Now let's do the partial pre-rendering. This is optional and you can pass a new experimental rendering model built with streaming. But anyways, we will do that. Now let's learn about partial pre-rendering, which is optional. It was introduced in Next.js 14. Partial pre-rendering is an experimental feature introduced in Next.js 14. The content of this page may be updated as the feature progresses in stability. You may want to skip this chapter if you not use experimental features. This chapter is not going to complete the course. In this chapter, what partial pre-rendering is, we will at least learn about this. We will not skip this chapter. How partial pre-rendering works. So what it is? Combining static and dynamic content. Currently, if you call a dynamic function inside your route, no store cookies, your whole route becomes dynamic. Okay, this aligns with how most web apps are built today. You either choose between static and dynamic rendering for your entire application or for specific routes. However, most routes are not fully static or dynamic. You may have a route that has both static and dynamic content. For example, let's say you have a social media feed, the posts would be static, but the likes for the post would be dynamic, or an e-commerce site where the product details are static, but the user's cart is dynamic. Going back to your dashboard page, what components would you consider static or dynamic? Once you're ready, click on the button. How would you split the dashboard route? Let's see the solution. Dashboard card is dynamic. Okay, it can change. Their values can change. This is dynamic. This is dynamic. So this is static. The home will always stay. Invoices and customers tab will always stay. They will not change. Side nav. Okay, component doesn't rely on data. Yes, it doesn't rely on data. So it is also not personalized to user. Everyone can see. Will see the same side nav. So it's not personalized. So it can be static. The components in page rely on data that changes often and will be personalized to user, so they can be dynamic. Everything that fetches data should be dynamic, I think. So now what is partial pre-rendering? In Next.js 14, there is a preview of new rendering model called partial pre-rendering. Partial pre-rendering is an experimental feature that allows you to render a route with a static loading shell. It is a new rendering model called partial pre-rendering route with a static loading shell. Okay, means everything else is static and you can have something dynamic inside it while keeping some parts dynamic. In other words, you can isolate dynamic parts for a route. For example, here number is static, cart is dynamic. User can change the items between in a cart. Product information remains same. Recommendation will change, dynamic. Okay, so they are static and dynamic components. Okay, there can be dynamic. So partial pre-rendering is you can have dynamic component inside a static shell or a static component. When a user visits a route, a static route shell is served. This makes the initial load fast. The shell leaves holes where dynamic content will load in async. Okay, the async holes are loaded in parallel, reducing the overall load time of page. They are like loaded in parallel, not in sequential. That thing needs to be keep in mind when working with partial pre-rendering. Partial pre-rendering combines ultra-quick static edge delivery with fully dynamic capabilities, and believe it has the potential to become the default rendering model for web application. They have given some link for this. Building towards a new, I think they have a blog post building towards a new default rendering model for web applications. Okay, let's for a moment read this. It is written by CTO of Versal, Martable, and Special Marketing React and Next.js. At this year Next, we discuss the developer and user experience challenges of global delivery of dynamic web applications. How can we fetch data without expensive waterfalls and also deliver content directly from Edge? The answer to all these current challenges: partial pre-rendering, PPR. PPR combines ultra-quick static edge delivery with fully dynamic capabilities and believe it has a potential to become default rendering model for web application. So this is a big thing, bringing together the best of static site generation and dynamic delivery. Today you can try experimental preview of PPR with Next.js 14 on Vercel, or visit our demo for the first impression of PPR and understanding the trade-offs eliminated. Okay, what PPR brings? Partial pre-rendering. PPR brings together the best aspects of popular rendering models, enabling both fast edge delivery, dynamic data access from core data centers. Okay, what are the differences? This is partial pre-rendering, this is edge server-side rendering, this is traditional server-side rendering, then this is incremental static. This is API request, jam stacks. Okay, so what is fast edge delivery? PPR has this, Edge has this. Okay, it doesn't have that. Does not block TTFP on cold start. Streaming dynamic content, it has no extra round trip for dynamic content. Okay, fast access to core region database and APIs. One simple programming model between statics and dynamic parts. Okay. So this is a partial pre-rendering like this. Now bar is static, cart is dynamic, image is static, product information is static, but its price may change in future, so it's dynamic. Okay, it can be used in any front-end framework through Vercel build output API. Okay, you can try the PPR on Vercel today by installing this Next canary. Okay, then in next config you have to write experimental PPR true. Okay, that was it. Okay, so this is a long blog post, but we will just go to our main partial pre-rendering documentation. So it's time for the quiz. Location with dynamic content will load dynamically, that is partial pre-rendering. How does it work? How does partial pre-rendering work? Partial pre-rendering leverages React's concurrent APIs and uses Suspense to defer rendering parts of your application. Some condition is met. Static parts are pre-rendered and the rest is postponed until the user requests the route. Suspense is a boundary between static and dynamic parts. The great thing about partial pre-rendering is that you don't need to change your code to use it. Okay, as long as you're using Suspense to wrap the dynamic parts of your route, Next.js will know which parts of a route are static and which are dynamic. So that means we have in our page.tsx, we have wrapped these components inside Suspense, so we don't need to do anything right now. So Next.js will know that these are dynamic components, right? Because they are dependent on some data. You can actually learn about this for now, but I will skip this because it may take more time to set up here. Let's just view the demo of partial pre-rendering. Okay, this is I think static, this is dynamic. These are images. Let's load it again. Okay. Okay, I think this is dynamic. Everything is static. Uh, Only these components are dynamic. So partial pre-rendering is happening. Static is route component is pre-rendered, and then dynamics are loaded. First they are loaded using skeleton. Okay, I think this should be also dynamic customer reviews. Okay, yes, this is also dynamic. So the red dots are artificial delayed responsive for demo purposes. Shop shipping estimates for millisecond products. They have put a delayed artificial delayed responses to show us how it works. Okay, so this is great. Partial pre-rendering. We will. So they have summarized this. Okay, what is the summary? To recap, you have done a few things to optimize data fetching in your application. We have created a database, Postgres with a Vercel. In the same reason, area application code to reduce latency between your and server database. Okay, fetch data on server with React server components. Used SQL query to fetch only the data we needed, reducing the amount of data transferred for each request, and also the amount of JavaScript needed to transfer data in memory. Parallelize data fetching with JavaScript. Implemented streaming to prevent slow data requests from blocking the whole page. And move fetching down to component need as where parts of your route should be dynamic. Preparation for partial pre-rendering. In next chapter, we will look at two common patterns you might need to implement when fetching data: search and pagination. So we have completed chapter 10. We have learned about partial pre-rendering and also early it rendering model introduced in Next.js 14. So next is chapter 11, adding search and pagination. So let's start. In the previous chapter, you improved your dashboard's initial loading performance with streaming. Now let's move on to invoices page and then learn how to add search and pagination. In this chapter, we will learn how to use Next.js APIs, search params, use path name and use router, implement search and pagination using URL search params. Start your code inside your dashboard invoices page on this. Paste the following code. If you go to invoices, do not have anything in this page. So now we are going to put some code here in our invoices page. We will copy this code and then remove it, paste the code. So this invoice is okay, already created for us. We have not created this route currently, So that's why it has given a 404 page error. Spend some time. Okay, we have a search, which is to search. It's this create invoices. Pagination is currently commented out. Table displays invoices. Your search functionality will span the client and server. When a user searches for an invoice on the client, the URL params will be updated. URL params will be updated and data will be fetched on server. When your user searches for an invoice on client, the URL params will be updated. Okay, data will be fetched on server. Table will re-render on the server with new data. Okay. Why use URL search params? As mentioned above, you will be using a search param to manage search state. Okay, we are not using any use state hooks of React. We're directly using URL search params to search state. This pattern may be new to you if you're used to doing it client-side state. There are a couple of benefits of implementing search with URL params. Bookmarkable and shareable URLs. Since the search parameters are in URL, users can bookmark the current state of application, including there are search queries and filters for future reference or sharing. Okay. Server-side rendering and initial load. URL parameters can be directly consumed on server. Okay, because we don't need to use any React state or initial state, making it easier to handle server rendering. Analytics and tracking. Having search queries and filters directly in the URL makes it easier to track user behavior without requiring additional client-side logic. Now we will add search functionality. These are Next.js client hooks that you will use to implement search functionality. First, you use search params. Search params for the URL. This is the search params like invoices, question mark, page is 1, query is pending. Would like this page, first page, and query pending. Okay, we'll get the data from URL, use path name. Let's read the current URL as path name, for example, route. Okay. Enables navigation between routes within client components programmatically. There are multiple methods you can use. Capture user input, update the URL with search params, keep the URL in sync with input field. Update the table to reflect the search query, capture the user's input. Go into search component. Okay, so first we need to capture the user's input. Go to search component. Okay, this is the search component. Capture the user's input. Go into use search component. You'll notice use client. This is the client component, and this is search input. We'll create a new handle search function inside this. So, and then add an on change listener to input element. We'll add on change handler event handler inside this input HTML tag. Okay. We can test it. It is client component, so we can test in the developer tools. We can open the developer tools. And we'll go to console, close this, and just enter something like laptops. Okay, it's refreshing. That's great. We're capturing the user input. Now you need to update the URL with search terms. We will use search params for this. Import it inside this, just below the magnifying glass icon. Search params from Next navigation. We will use this. Const search params is equals to use search params. So inside the handle search, we will create a new URL search params instance using your new search params variable. Params is equals to this URL search params inside our handle search. A new URL search params. We will pass our search params instance inside this. URL search param is a web API that provides utility methods for manipulating URL query parameters. Instead of creating a complex string literal, you can use it to get the params like Next, set the param string based on user's input. If the input is empty, you want to delete it. Okay, if there is a term, we want to set query as term, else we want to delete the parameters. Just paste it here. The place of console log. Okay, now that you have the query string, you can use Next.js use router and use path name hooks to update the URL. Okay, import user router and use path name from Next navigation. Use router, use path name. Okay, we have imported both hooks from Next navigation. We will use replace method from use router. I think this to replace the URL with our query string. Okay, then replace path name with replace this URL with this query string params to string path name. We have not used path name. Okay, path name. We have to use path name. Use path name. Path name is the current path, in your case dashboard invoices. So this is our current path, dashboard invoices. Now as the user types into search bar, param_toString translates this into URL friendly format. So this will convert it into URL string. Will update the URL when the user search data. For example, searches for Lee. URL is updated without reloading the page thanks to Next.js client-side navigation, which you learned about in chapter on navigating between pages. Okay, if I put here in laptop, you can see here it is updating. If I put here mobile, it is putting. If I just clear this, query is clearing, right? Let's put iPhone. Okay, so query is queries equals to iPhone, right? So our URL updation is working, keeping the URL and input in sync. To ensure the input field is in sync with the URL and will be populated when sharing, you can pass a default value to input by reading search parameters. Now keeping the URL and input in sync, to ensure the input field is in sync with the URL and will populate when sharing, you can pass default value. We will put a default value inside input. We will close this console for now. We're not using state, that's why we'll use default value. That means native input will manage its own state. This is okay since you are saving the search query in the URL instead of state. Okay. If I do not use default, will it just okay? So if I do not use default, the text inside this search box is getting reset. So if I use default value, it will preserve this value. So default value is search parameters. It will get the value from search params, that is use search params. Okay, cool. Now updating the table, fourth point. We will go to dashboard. With dashboard invoices page.tsx. Just move this little bit to the right. Now they are saying we have to use the props called search params. Okay, we will use this prop inside this search params. It's query, it's a page, query string, page string. So query is search params query or empty string. Current page is number, search params page or 1. So if nothing is entered, it will be empty string. If no page is entered, it will be first page by default. So inside Suspense, we will uncomment this code. Okay, we have now table rendered. Okay, nothing is rendered right now. If you navigate to table component, there are two props passed to the fetch filter invoice function, which returns invoices that match query. Let's go to the table code. This is the invoices table. Fetch in filtered invoices that has query and current page. So we have filtered invoices. It is accepting query and current page. Then it's implementing a SQL query on the invoices table. Then returning the invoices rows. Okay. Now what? Now if I search something in the invoices, let me see what's inside the data. This is customer, this is invoices. Let's put ML Kowalski. Okay, it's working. So our table is now working. If I go to full screen, let me go to the full screen and test how it's working. So here is our table. Let me zoom out a little bit. So these are the users in our table. As you can see, let me check Lee Robinson. Let me check. Let me clear this. There are two entries for Lee Robinson. Okay, it's Lee Robinson's email, amount, date, status, paid. Okay, pending. This is a great looking actually table. Great. So our invoices table is almost ready. Let's try out some more data. If I put the email here, will it search? Let me put the email here. It will also search by email, I think. Okay, it's also searching by email and giving the name Dalba di Oliverio. So it's fetching the data from our database. That's great. So what next? Search is a client component, so you use the search parameters to access parameters from client. Table is a server component that fetches its own data, so you can pass the search parameters prompt from page to the component. As a general rule, if you want to read the params from client, users use search params, as this avoids having to go back to server. Okay, so now best practice debouncing. Congratulations, you have implemented search in Next.js, but there is something you can do to optimize it. Inside your handle search function, add the following console.log. We'll close this, close all the, where was our search? Okay, inside its handle search, they are saying to put a console log here, then type email, then you search for checks console. What's happening? So if I go to our developer tools, console log, if I enter something like Lee Robinson, you can see it is getting updated word by word. Okay, you're updating the URL on every keystroke. Therefore, querying in database on every keystroke. Okay, that's right. We are querying our database on every keystroke. Like Lee, then if I put E, then again it will query, then again it will query, then again it's happening again on each keystroke. This is not problem as our application is small, but imagine your application thousands of users is sending any clustered database on each keystroke. That will be very much pressure on the server. That will be huge pressure on server. Server might not be able to handle that. So debouncing is a programming practice that limits the rate at which the function can fire. In our case, you only want the queue to database when the user has stopped typing. How debouncing works? Trigger event: when an event that should be debounced like keystroke in the search box occurs, a timer starts. Wait, if a new event occurs before the timer expires, timer is reset. Execution: if the timer reaches the end of its countdown, the debounced function is executed. You can implement debouncing in a few ways. We will use library use debounce. Okay, we will install this library and npmi use debounce. Open our terminal. Okay, it has installed the package. We'll close our terminal. We will import use what was it? We will import use debounced callback from use debounce library we have just installed. Okay, they're saying that we have to wrap the handler search inside use debounced callback. Wait a minute. We will convert this function component to arrow function. We will wrap this into debounced callback, right? So we have wrapped our handle search inside use debounced callback. This function will wrap the contents of handle search and later on the code after a specific time when the user has stopped typing 300 milliseconds. Have I put 300 milliseconds? Okay, here 300 milliseconds. So it will run after 300 milliseconds. Now type in the search bar again and open the console in dev tools. These are things that really put you apart from other front-end developers. So let's again put it Lee. Okay, it's only waiting 3 milliseconds. If I keep typing, it's not actually sending request. Only if I stop typing, it will send request. So that is the feature of debouncing. So when event is triggered, when we press our key, a timer starts. Now if a new event occurs before the timer expires, the timer is reset. Okay, before 300 milliseconds, if we press again a key, it will reset to again 300 seconds. Oh, like if I type it fast. Okay. Yes. So if I keep typing, it will not. Timer is getting reset. So that's the thing. But 300 milliseconds is still very low time, I think. I think the best way to is put a search bar here, and user will only search by clicking on this search button. Now let's check by putting the I'm not supposed to open the I was supposed to open the console log. Just reset it, put ml. Okay. If I type it fast, whole ml text is going to server, not the emil. So that's the power of debouncing. It prevents new database query on every keystroke. Now we will add pagination. Now let's search, let's do the pagination now, adding pagination. After introducing search feature, you will notice a table displays only 6 invoices at a time. This is because we have used fetch filtered invoices function in data test in a maximum 6 invoices. Okay, in the data.ts, where is it? If we go to fetch in latest invoices, it is only limiting to 5 records. So that's why it is fetching 6 invoices per page. Pagination allows users to navigate through different pages to view all the invoices. Let's see, you can implement pagination using URL parameter just like you did with search. Okay, navigate to pagination component. You will notice it's client component. In the search, go to the pagination. Let's explore its code. They will use search params, path name, handle search. Wait a minute. We are supposed to go to pagination. Okay, this is the pagination component. Close this search. They use some classes, links, pagination arrow. Okay. We will see later what it's doing. You can fetch data on server, pass it to the component as a prop. The dashboard invoice page import a new function called fetch invoices pages. Invoices pages. Okay. Inside invoices. And put it inside a variable total pages inside your page. Okay, total pages, fetch invoices pages, return the total number of pages based on search query. For example, if there are 12 invoices that match the search query, each page displays 6 invoices, then the total number of pages would be 2. Right. Next, pass the total pages prop to pagination component. Let's uncomment this. We're passing this total pages to the total pages component, and we also need to uncomment the code inside pagination. Uncomment this code. Now to pagination component, import the use path name is search params hook. Let's import use path name and use search params from next navigation. Okay, we will copy this code inside our pagination. Also uncomment this line. Okay, we have to use it above this. There was a block scope error because we have used current page after this all pages. So after that, next create a function inside pagination component called create page URL. To search, you use URL search params to set new page number and path name to create URL string. Okay, create page URL. It is taking page number. It is searching params and setting the page to page number dot string. I think this is used inside pagination arrow, pagination number, pagination arrow. Okay. It is a breakdown what's happening. Creates an instance of current search parameters. Okay. Then it updates a page parameter to provide page number. Okay, it will update our URL with page query. Finally, construct full URL using path name and updated search parameters. The rest of page deals styling and different states. So finally, when the user types a new search query, you want to reset the page number to 1. You can do this by updating handle search function in your search component. In our search component, we will remove this console log and put params.set and set page to 1. Okay, 1 should also be string. Okay, let's search the pagination if it's working. Let's remove this ML. Okay, it's working now. So this is the pagination. We can see the numbers now. If I click on 2, okay, it's going to second page. If I click on 3, it's going to third page. Great. If I go to second and write email, will it reset? Okay, it reset to first page. Now we are only seeing first page because we have only one record. Right. So we have implemented search and pagination using URL params and Next.js APIs. To summarize, you have ended search and pagination with URL search parameters instead of client state. We have not used React hooks to handle this pagination or search. You have fetched it on server. You're using user router for smoother and client-side transitions. These patterns differ from what they are used when clients, but hopefully you now better understand the benefit of using URL search params and lifting this state to server. Okay, we have completed chapter 11. Your dashboard now has search and pagination functionality. That's great. That is great. We have now also search and pagination. Great. Next is learn how to mutate data with server actions. Now let's learn how we can mutate data. The previous chapter we search pagination. Now let's continue working. In this chapter we will learn what server actions are. Okay, we will learn what are these server actions and how to use them to mutate data. How to work with forms. Server actions are mainly used with forms, so that's what we will learn. And also with server components. Best practice for working native form data object. To revalidate client cache. How to create dynamic route. How to use React's use form status hook. Okay. So I will end the stream here. We will cover this mutating data chapter in the next stream. So stay